Good morning to one and all. In this video lecture, I would like to discuss about the concept buffer register and control buffer register. So let us have the look into circuit diagram. So this is our buffer register circuit diagram. So in this buffer register circuit diagram, simply I use 4D flip-flops. So buffer register can be used for the storing of the information, or else we can load the information. So we can use the D flip-flop for this particular purpose. So here we can store the 4 bits of information into this particular buffer register. So let us have the first bit as x1, x2, x3, x4. So and the corresponding outputs are q1, q2, q3, q4, and this is all which is dependent on the clock pulse only. So whenever you have a clock pulse for positive edge triggered or negative edge triggered, then only my input whatever I am considering here, that will be coming as it is at the q1. In the similar way for q2, in the similar way for q3, in the similar way for q4. So let us consider the first example. Let us consider my choice is 1011. So if I consider this as my input, so simply I will store this information inside this particular flip-flop as 1011, and after that storing you will get your resultant at this particular q1 as if your input is 1, you will get your 1 as output. So 0 as it is, you will get your output 1 and 1. So therefore we can state here whatever I am giving my input, whatever I am giving my input, that is coming as it is. So therefore I can state that here x1, x2, x3, x4 is equals to q1, q2, q3 and q4. So therefore simply we can state that it is a x is equals to Q. So this is what a buffer register. So buffer is nothing but we can store the 1 bit of information or 2 bit of information or 3 bit of whatever it may be. Choice is ours. So depends on that. We need to select the number of flip-flops to store the data. So which is all dependent on the clock pulse only. So whenever the clock pulse is occurred, we'll store the information and we'll get the resultant. Now here for this x1, x2, x3, we don't have any control here. So in order to have the control for the inputs, we need to have the here load as my controlling input. So next one is here control buffer register. So here control buffer register will be explained in this particular. So this is our basic circuit diagram for the control buffer register. So for each flip-flop I am using two NAND gates and one OR gate, two NAND gates and one OR gate, two NAND gates and one, like this I am connected for this. And the output is connected to the one of the input for the NAND gate. The output Q2 is connected to the one of the input to the NAND gate. The output Q3 is connected to the NAND gate, and output Q4 is connected to this particular NAND gate, and correspondingly I am giving my one of the input to the another NAND gate as x1, x2, x3, x4, and load is directly connected to the one of the AND gate, and load bar is connected to the another NAND gate. So let us will have one example here. Initially if clear is equals to 0, so let us have the statement. So here I mentioned here clear bar. So when clear bar is equals to is equals to 0, so what will happen? And again clear bar is equals to 1, then what will happen? So clear bar is equals to 1, so then what will happen? So this is what I will explain initially. After that I will go for load. So now, so here when clear bar is equals to 0, so means clear bar is equals to 0. So it is going here. So we have a bubble here. So when clear bar is equals to 0, 0, 0, 0 to the bubble means it is giving your input as 1. So therefore simply we can state that when clear bar is equals to 0, it means that I will show you. It means that reset state is occurring. Reset state is occurring. So it means that we don't get any output at this particular point. So simply you are getting your output as 0 0 0 0. So it is reset state is occurring and your corresponding outputs are 0 0. So this is what you will get your output at that particular end. So when clear bar is equals to 1, it is nothing but high state when the particular flip-flops will work. So then flip-flops will work. Flip-flops will work. Now, now, whenever this particular action is changing from clear 0 to clear 1, then load will takes place. So at this particular time, load will come into existence. So when you consider load is equals to 0 and load is equals to 1, what will happen? So I will show you when load is equals to 0. So let us consider, if I consider load is equals to 0. 0 means the load is coming to this particular position and then it is going here. So 0 into x1. So this is output as 0. And similarly this output as 0. And similarly this output as 0. And similarly this output as 0. Therefore we can understood that Q1 is again given to the input. Q2 is again given to the input. You can observe Q2 is directly connected here and Q1 is directly connected to here and Q3 is connected to again to this and it means that previous state is existing in the as a next state only. So it means the storing of information taking place. So when load is equals to 0. So when if you consider load is equals to 1, I will show you. So let us consider when load is equals to 1. So when load is equal to 1 means it is going here. So 1 is one of the input here and 1 is one of the input here and 1 and 1. So the another input for this particular gate, first AND gate 1 into x1. So my output is here x1 and this is 1 into x2. So this is my uh, x2. So this is my second gate. And if you consider for third gate, so your output is x3 or x2. Like that you will get your outputs. So and finally you will get your output as x1. So this won't will work. Why? Because load is equals to 1 means your after inverter you will have your signal as 0. Therefore one of the input is 0. So 0 into anything is 0. So this gate is 0 and this gate is 0 and this gate is 0 and this one is also 0. Therefore x1 plus 0. So your input is directly connected to the D1. So x1 is directly connected to the D1 and in the similar way x2 is connected to the D2 and x3 is connected to D3. x4 is connected to D4. Therefore here we can state that again control buffer register. So here my controlling operation with respect to load. So when my q is equals to x, it means that so here my controlling state is occurring for the buffer register and I am giving my input x. So let us consider my x as 1 0 double 1. So directly I will get my output here as 1 0 double 1. So this is what a buffer register with respect to load concept. So whenever load is equal to 1 means it acts like a buffer. Whenever load is equals to 0 means it is nothing will do and it will be an ideal state. When clear bar is equals to 0, all the outputs are reset state. When clear bar is equal to 1, now flip flop will work. With respect to these, all conditions are when clock is positive edge triggered or negative edge triggered. So whenever clock is only there, then only it will work. So this is what controlled buffer register and buffer register. Okay, thank you.